All right, so today we're going to finish off about inheritance. We definitely got a few very important concepts, especially polymorphic collection. That's really why we're studying so much about inheritance. That's really the final product we want to really gain. We'll talk about it, do lots of tracing. And then, let's see. And then I'm hoping that I can at least do a little bit introduction about recursion. We're definitely going to dive a little bit deeper next week, and also the last class in the final week. So your lab number 4 solution has been released. So next week this time, next Wednesday this time, and you will have your programming test number 3. So that'll be the final test for the term. And you gotta make sure you submit, you gotta make sure you study for lab 4. And also there might be exceptions, you gotta study for that as well. Okay, just make sure you kind of review the stuff. And the guy example questions has been released already, okay? Any questions? The TA are already started grading for your programming test 2. I'm hoping they can get back to me on Friday afternoon, late afternoon. And then I just need to process them very quickly, and then I will try to get back to you over the weekend, maybe Sunday. Okay, I'll get back to you. You can see the result, the feedback, and if you want to talk about the test, no problem. Just visit my office hour. Always happy to talk. Okay, let's now do a very quick recap from Monday. And then, let's see, and then we'll continue from there. Okay. So on Monday, we actually talk about instance of operator, okay? So the way you want to think about the instance operator is, it's really more like a safety check for doing some subsequent typecast. So in short, whenever you say X instance of Y, you're basically asking, is it safe to cast X into Y? Both compiles and also class cast exception free. The way it works is like this. Instance of is a Boolean operator. It's going to return either true or false. But even before it can evaluate to true or false at the runtime, you have to worry about whether or not instance of is going to compile. The way it's going to compile is just like a typecast. So the easiest way to think about is, if I try to cast X to Y, like this expression here, if this expression here represents either upward cast or downward cast, it's going to compile. If the typecast compiles, the instance of is going to compile as well. They go together. And then at the runtime, can the dynamic type of X fulfill the expectation of Y? If it can, we wouldn't get any runtime like a class cast exception, in which case the instance of is going to return true, evaluate to true. On the other hand, if the dynamic type for X cannot fulfill the expectation of Y, meaning that if the dynamic type of X is not a descendant of Y, in that case, of course, we might get the class cast exception if we do the cast. But in this case, instance of is going to give you evaluation result false, in which case you can use an if condition and try to bypass. That's really the essence about these two. So later on, when you study for the exam, I will highly recommend try to really connect the instance of and typecast together. They usually kind of go together. Again, you don't really have to do like an instance of check for every typecast you're doing. You don't really have to. You got to strike some balance. Exactly what the balance is, you will need to gain some experience on your particular developments, right? That's something I wouldn't enforce, for this course. You just got to make sure you know how to use it and also how to judge about compilation and class cast exception, condition. All right. Any questions about instance of? Okay. And then we talk about generalization. Okay, I'll let you study the detail. So I made some mistake on Monday about the written notes. I already fixed it. So if you look at the post-it note, it's already fixed it. And that's the part we did on Monday. Okay. And then we talk about, just about using the instance of check. You can review the detail. We did lots of examples on Monday, right? So all these are good. And then let's now take a look at this, because we're going to do one more example about polymorphic arguments. So we basically revisited the call by value concept every time you have a method called like this. In which case you got arguments. Accordingly, you got some method declaration with parameter. Call by value tells us you're going to assign the argument value to the parameter, right? That's always the assignment we are talking about. And whenever you have a variable assignments where both sides are reference type, and also you have some inheritance hierarchy in the context, that way you have to worry about the rule of substitution. You got to make sure the static type of the right-hand side must fulfill the expectation of the static type of the left-hand side, right? That's a complete description. Or you can think about a static type of argument should be a descendant of the static type of param. right? That's also kind of relevant to today's test. So this kind of condition, you want to make sure you kind of understand. I wouldn't so recommend just memorize it without understanding it. It's not going to lead you for long, right? You definitely want to keep the knowledge, keep the understanding beyond this course. Any questions about call by value? Okay. And then we spoke about whenever you got a method call right here, for example, add rs. Oh, let's just move on directly to this example here. If I have add rs method here, right? The parameter rs statically is resident students. That would mean I can only pass arguments whose static type is a descendant class of this. In this case, I only got one choice, which is resident students. So that's why when we did an example together on Monday, this is the only one that's going to compile because the argument rs has the static type resident student. That's the only one. It's going to fit the criteria. On the other hand, this method here is very accommodating. This is something we're going to see more example a little bit later today. In this way, the static type for the parameter is students. So that would mean any argument whose static type is a descendant of students, which can include either student itself, resident students, or non-resident students. So everything in the hierarchy, because we simply put the top class in the hierarchy as a parameter type. That's very accommodating, and it's going to give us something called polymorphic array. Polymorphic in the sense that each element in the array has some static type, but dynamically, their dynamic types are simply just different, which we'll see. And of course, if their dynamic types are different, you will actually have to use your knowledge or use the syntax about instance of and etc. Dynamic binding knowledge like that to really judge what the runtime behavior accordingly. That's something we'll see. Okay. Any questions about this one here? Okay. All right. Let's now do one more example here. Okay, just about typecasting, polymorphic argument. Let's put them together. I think this one would be kind of interesting to actually see. Okay. So let's now focus on calling this particular method add rs. So static type for the parameter rs is resident students. Let's start with that. Okay. And on the slides, it's basically multiple slides starting from slide 79. I'm going to compare all of that at one go. It's just more efficient for you to see what's going on. Okay. So now we're calling this method here. For now, just disregard this line, just for now. Okay. So we're calling this method here. And then we have different call right here. We try to call add rs, add rs, add rs, and also add rs here. We call it 4 times. Okay. And then you can see that here we're passing one argument here, s. Static type is students. And this we know it's not going to compile. Simply because, let me just do this one here just again. Right? If you look at that, s is the arguments, and s over here is the parameter. So if you try to connect them, right? So just, even though they're called the same name, but their scope is different. Let's say this is green, the arguments. This is blue, maybe orange. Okay, that's the parameter. Okay, so call by value is basically doing the parameter s is assign the argument s, right? And argument here has the static type students. Static type is students. Versus for the parameter type s for, there should be resident students. So that one there, the static type is resident students. So we're asking, can student fulfill rs? No, it cannot. So it doesn't compile. Okay. So if you look at all these lines, 1, 2, 3, student, 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 they wouldn't compile for the same reason. Doesn't matter what the dynamic type is. Similarly, this one here, we are passing another argument, but it's non-resident student. Can non-resident student fulfill resident students? No, it also cannot, right? So this one also would not compile. All right, so far so good. Let's now try to add something a little bit additional. Let's see if we can cast the argument before we pass it. So especially we're doing anonymous cast. Okay? So what we are talking about right now is this expression here. So I want you to now consider this particular method call right here. This one here. Okay? So I'm using this. Okay? Basically, I'm going to replace this line here by this line here by this, and also this line here also by this. Okay? I'm doing some replacement. First of all, let's see if they will compile. Okay? If you look at this cast over here, right? Let's analyze carefully. Okay? So let's now isolate this cast right here. Oh, sorry. Okay, let's analyze just this particular cast, right? So the star, I'm going to put it here. So this particular cast, does it compile? Right? That's the first question. So if you look at static type for S right here, it is students, basically, right? In this case, students. So we're doing downward cast. So we're doing downward cast from students to resident students. Again, we're talking about the S over here. They can be applied the same way. Students down to resident students. Okay, they compile. And then, since they compile, the entire cast expression over here, the one I'm boxing, that one there has the static type, resident students, corresponding to the cast type. So the static type of the cast expression will be corresponding to the cast type, which is resident students. So now, if I pass the entire cast expression as argument to the method call, is it going to compile? If you think about it, so now the right-hand side for the call by value has now become resident students. Can resident student fulfill resident student itself? Of course it can. So it's going to compile. All right. So if you think about, if I replace this line over here by sms.add rs, and then I do that cast, which I just put here, it's going to compile. Okay. Similarly, if I try to replace this one here by the same line, it's also going to compile. And this one here is also going to compile. Okay. I'll worry about this a little bit later. Okay. Let's do the isolation. So all these three compiles after I cast the arguments. So that's the number one thing you want to learn from this example here. Whenever you want to maybe pass an argument for method call, if at the moment the static type for the argument doesn't really fit into the parameter type, in that case, you might consider doing some cast. You might just be able to work around at least the compilation. Okay, that's number one. But, if the cast compiles, the next follow-up question will be, would it run into class cast exception? Right? Phase number two. These three. One here, and one here. Are we going to run into class cast exception? Let's judge case by case. Right? In order to judge if we got class cast exception, now we cannot rely on static type anymore. We have to look at the dynamic type. In which case, we got to look at, for example, the dynamic type for the first one here will be students. And the second one there will be non-resident students. The third one there will be resident students. Right? So for the same method call repeated here, here, and here, which ones is going to give us class cast exception? Okay, Daniel, you try first.
I think the second one is going to give us.
The second one is going to give us class cast exception. Okay. And the first one as well. Okay, I like it. Would you like to explain a little bit?
Yeah. So students is class higher than resident students.
Yeah, I know exactly what you mean. But I think just for you to answer like a written answer, you want to be more complete in this case. I know exactly what you mean. Okay. Let's say for the first one. Let's say for the first one, I'm judging for this line here, right? Dynamic type is students. Easy. Can students fulfill resident students? It cannot, because student is not a descendant class of resident student. So class cast exception. Okay? Let's write it down. So the first one here, yes, class cast exception, because dynamic type of S right here which is students, cannot fulfill the expectation of the class type, which is resident students. All right? And the second one there is also going to fail for a similar reason. So here you can see the dynamic type is non-resident students. Can non-resident students fulfill resident students? Also, it cannot because it's not descendant class. Okay? So also, yes, class cast exception because dynamic type of S, in this case, it will be non-resident students. Non-resident students is not. So I'm just trying to write out different possible explanation you can put in the exam. In case I give you open format, you can put either way. It's not descendants of the class type, which is resident students, right here. And the third one is actually the only one that's going to work, because in this case, resident student is the dynamic type, which can fulfill the class type itself. Okay? So in this case, it will be no. Class cast exception free, because dynamic type is going to work. All right? So in some way, this is really something you have been studying for, right? Just to see, whenever you want to judge to see if a typecast that compiled is going to run into class cast exception, ask about the dynamic type for that particular object. Is it going to fulfill the expectation for the class type? All right, final one, and then we conclude this example. How about this one here? If I try to do SMS add RS, and then I say I want to cast NRS to resident student so that the static type for the cast type can be resident students, which can fulfill resident students. Oh, sorry, can fulfill here. Is it going to work as I hope it would? Anybody? Go ahead.
It wouldn't compile.
You mean the whole thing wouldn't compile? How come?
Because trying to translate the static type of NRS is non-resident student, which kind of fulfills.
Yeah, that's good. Okay. Because the cast itself is not even going to compile. If the cast is not even compiled, you cannot assume it has certain static type. Right? Okay, that's good. Awesome. So this one here is even not going to compile. Okay, I will put a star here. So star. This cast over here is not compiling. Because the NRS over here has the static type non-resident students. So you're basically casting from non-resident student to resident students. You're basically doing this to over here. It's neither upward nor downward cast. Okay? It's neither upward nor downward cast. All right? So this example here, so try to study them more carefully because it really go across multiple slides, but it's really talking about the same thing. So whenever you want to make a method call and the static type for the argument doesn't quite work, you might be able to work around using some typecast. You can even say upcast and the downcast, like what we said the other day. But even that, you still got to pay the price, possibly, very likely, at the runtime, if the dynamic type cannot really fulfill the cast type. Okay? Any questions about this example here? Okay, good. And then let's now move on to, I would say, arguably the most important page, for the course. Okay, well, for inheritance at least. Okay, so here I want to talk about polymorphic collection of students. And for this one here, I want to again draw some connection to you. And that's something you definitely want to make sure you revisit when you study for the exam. Okay. So we are done with this. Basically, all the examples here. Okay, they're done. Okay. So now slide 83. Do you remember this page kind of referred to maybe about 5 lectures ago, right? So let me remind you quickly. So here, now that we have inheritance basically thoroughly discussed, so now we are able to declare an array of static type students right here, and then we're gonna trace many things over here. We'll do that in a moment, but you really want to compare this version of inheritance solution with the ones we talked about earlier, like a design number 2. Okay, let me show to you. If you click on the link at the bottom here, it'll bring you back to slide number 11. And that's the one we said, if you don't really have inheritance, and then the resident student and non-resident student, they're not really related to each other, in which case you got multiple arrays, multiple counters, multiple loops. That's a bad solution. Even though it might work, but it's a bad design. And you want to see how we can transition from this solution here all the way to right here, right? So from slide 11 to slide 83. Okay, that's one connection you want to really try to convince yourself when you study for the exam. Okay, but let's now try to trace what's going on, what I meant by polymorphic collection of students. All right, let's now take a look. So we have some example code. We're going to go over line by line. We also have our student management system class as well. Okay, we'll look at that bit by bit. Let's start with what we really meant by polymorphic collection. Okay, let's clarify this term right away first. Polymorphic collection. This simply means we have a collection where dynamic types for each element might just be different. That simply means elements in, for example, array may have different dynamic types. But their static type is the same. As you can see here, when we declare student management system, the static type for all the elements in the array is students. Statically, every element is a student. Dynamically, there might be any descendant class of students, which can be, of course, student itself, but typically it should be resident students or non-resident student. That's something we'll see how we can construct such polymorphic array. Okay? And in this class over here, we have our students, we have our counter, right? Usual programming pattern that we have been getting used to. We got one method for adding student. I chose the most accommodating type for the parameter, right? So here I'm saying arguments whose static types are descendants of this can be passed. Which means if the variable, the argument I want to pass into this method call, if it is actually student itself, or it could be resident student, or it could be non-resident students, right? It's the most accommodating method call. Basically anything, as long as it's a descendants class of students, all right? So that's another thing you want to notice. We choose this most accommodating version to go with. All right, so inside we just do the normal pattern, just assign the objects and then increment the counter. Okay, and then we simply just have some method here, register all. We just want to register all the students into a common course, for example, 2030. And then this one here, we just say students at index I dot register. If you recall, register is simply just a method in the student class. In this case, it's not really overridden. So you can think about there's only a single version of register that will be inherited to this and also this. But that's okay. We can look at get tuition in another context. Okay? And one thing to really note is this. Okay? So here you're going to see students at index I, right? For example, index, the I value, as we'll see a little bit later, can be of value 0, can be of value 1, for example, right? Let's say we got 2 elements in the array. Let's say two students. They might be of different dynamic type. Okay? For example, at index 0, dynamic type could be, for example, resident students. At index 1, dynamic type could be NRS, could be, right? In this case, when we try to invoke the method, we have to apply dynamic binding principle, in which case the register version that will be called correspond to the dynamic type. We'll get to there once we get there. I just want to give you some quick preview. Whenever you see any kind of like a polymorphic array and have the method call, you want to have some idea even before you start tracing, right? All right, so that's about a student management system we have to know. Let's now talk about this fragment of code just to see how we can construct the array and do some basic manipulation. Okay. So let's now start with just a few lines just to do some basic object creation. So I'm going to get number 1 to number 6. So just to save the time in the class, I try to kind of put the final diagram already on there so we can just look at it. But I would suggest you may actually just want to practice maybe tracing from scratch. That could be a very nice practice, just in case I give you something similar but not exactly the same for the exam. You may want to try to trace from scratch and compare with this diagram here. Okay, I'll leave that to you. All right, so let's now take a look. So we got actually different parts. Let's go line by line. So first of all, we got RS, dynamically resident students. We got RS, dynamically resident students. Okay. So let me just try to highlight differently. Okay. Let's say we got RS, dynamically resident students. So you can think about this is dynamic type right here. Okay. And we got another one. Let me use pink. We got also NRS, which is a non-resident students right here. So dynamic type is right here. Okay. So we got RS and RS. And we try to set their premium rate and discount rate, 1.5 and 0.5. Okay. And then we create some student management system. And student management system has an array and also the counter. All right. And then we try to call as students 2 times. Okay, let's see exactly how things will work. Okay, let's go for line by line. When I do, for example, this line here, sms.addStudentsRS. Okay, of course you can judge right away, is this method call going to compile? Very quickly, RS statically resident students. Can resident students fulfill students? Yes, you can. So it's going to compile. Similarly, NRS statically non-resident students. Can they fulfill students? Yes, you can. Right? That's kind of the thing. It's something you got to do proficiently and also quick. So this one here is simply going to add index 0 of the array, let it point to wherever RS is pointing to. Okay. So this one here is actually going to just do this particular assignments. Okay, just that. So now at index 0, we got resident students. The next line, we got right here, NRS. That one there is actually going to let index 1 point to wherever NRS is pointing to. Okay, right here. So that's another one. You can see NRS here. Okay. After these 2 lines, we actually got 1 and 2. Students stored at indices 0 and 1 for the student management system. Okay? And we also create EECS2030. So that's a course, right? We try to register this particular course for both students. And they'll get tuition at some point. Okay? So let's now try to see how we are going to call this method here. So let's see this one here. Okay, line number 9. Right? Register all. So we are calling this method here, register all, right here. And that one there, we are going to basically run a loop. And the loop is actually going to go from 0 and less than number of courses should be actually 2. All right? So we're going to go for 0 and 1, exactly how I kind of look ahead, right? So now there are going to be 2 iterations. Let's just do that kind of efficiently. For iteration number 1, I value will be 0, in which case we will be looking at this particular index. That one there is actually going to point to this particular objects. Agree? Okay. So that one there is actually going to look at SS at index 0 for the first iteration. And let's do a little bit of instance of check that we are familiar. All right. Now I want you to look at this fragment here. Okay. We know that for register all, we're going to run 2 iterations in total. The first iteration, the I value will be 0. And then when the I value is 0, that means we're looking at the array at index 0. That is pointing to this particular objects. Dynamically, it is resident students. Let's now try to evaluate all these 3 instances of check. Okay. Of course, I'll leave as exercise to you why all these 3 instances of check should really compile. You want to think about it. Okay, they compile. But now I want to ask for you, since they all compile, what's going to be the evaluation result for each one of them? True or false, basically. Right? I'm only looking at one particular object, right? Which is at index 0. That one there you can see from the tracing result what is its dynamic type. Once you know it, you will be able to judge. Yeah, go ahead.
Would it be false, true, false?
Let's try. Okay. So we're basically asking, can the dynamic type for this object here, which will be resident students, can resident students fulfill non-resident students? Apparently it cannot, so that'd be false. That's what you said. Good. I agree. And then this one here, can resident students fulfill resident students? Yes. And then, can resident students fulfill students? True, right? False, true, true. I think you said one thing wrong, right? Am I right? Okay, yeah, just be careful. Okay. False, true, and true. Right, so these are the evaluation results. So you want to know 2 things about this instance of check. Number 1, does it compile? You just want to see if the corresponding typecast is going to compile. I'll leave that as exercise for you. Number 2, when you do the instance of check, given that it compiles, it's going to return false or true, true or false, right? And the check, again, you want to do will be asking whether or not, and let me do one more thing for you, because all these right here has the dynamic type corresponding to here, resident students. Can resident student fulfill non-resident student? False. That's the only one it's not going to say true. All right, and then for register all, and then for the second iteration, we can actually go to index 1, right? For index 1, so now we are looking at a different element here with a different dynamic type, potentially. Indeed, it is a different dynamic type, right? So here we got SS1. And then over here, you can look at dynamic type over here is non-resident students, right? Because, and now, what will be the instance of check right here? Anybody would like to give it a try? Again, they still compile. Okay, I'll leave that exercise. But give me the result, true or false. Go ahead. True, false, true. Sounds right to me. Okay. So, given that dynamic type is actually non-resident students right now, right here. So now, non-resident student can fulfill itself. So that should be true. And then, non-resident student cannot fulfill this guy here. Also cannot fulfill students. True, false, false. So if you compare the result from different iterations, that's really give you the essence about polymorphic array. Because in this case, you're looking at just different index between iterations, in which case, the particular object you're referring to may just have different dynamic type. In that case, when you call, for example, get tuition, you're going to get different result. I'll get there as well. Okay, okay, final thing. Let's now look at, again, another loop. If I look at line number 10, right here. Okay, so still I'm going to go to index 0. I will be index 0 and index 1, right? And then when I over here is actually index 0, that means I will be referring to here, right? That way I know that dynamic type is resident students. In which case, if I call get tuition, which version? Resident student using premier array, right? Exactly. And then if I go to iteration number 2, I would be incremented to 1. In that case, the dynamic type has just become non-resident students. In that case, if I try to call the get tuition again, it's going to give me the different calculation mechanism. Base amount apply with discount rate. Okay? Yeah, so I think that's about all I want to say about tracing. Any questions? Any part that's not so clear to you? I don't mind slow down. Okay, go ahead.
I was just asking again.
Yeah.
SMS SS1
Yeah.
Instance of student, is that supposed to be false or is it supposed to be true?
It's supposed to be true. Actually, I put false, right? Okay, that's my bad. Absolutely. Because you are because this NRS is a descendant of students, so that should be true. I agree. Thank you. Very nice. Yeah, you can see between the two iterations, this one here is false, but this one here is false, right? They are kind of false in different places. All right, any questions about this? Yeah, Daniel.
So is get tuition defined in both resident students and non-resident students?
Sorry, say it again.
Is the get tuition function defined in both resident student and?
Of course. Yeah, if you recall the details about the inheritance, let's do that quickly, right? So remember what we had earlier, we got students which already declare get tuition. That guaranteed the default version that calculates the base amount is going to be inherited to both subclasses. But in the resident student, we choose to override it by applying the base amount using super with the premium rates. And here as well with the discount rate, right? That's a detail we had. Yeah. So if the dynamic type is this, call this version. If the dynamic type is this, call this version. Yeah. Okay, questions? Anything? All right, why don't we take a short break and then we'll come back for two more examples. Okay. All right, let's now do a little bit more about polymorphic array. So what we just discussed before the break was this one here, 84. Okay, we just did it. And let's now take a look at return type for method, especially accessor. Okay, let's take a look at that. Okay, I'll show you too. I'm going to trace some code as well. Okay, but before that, let's look at this simple method here. So let's say in our student management system class, and we have our student array, right? Statically, every element is students. We know that pretty well. Let's say of course, we also got to ask students the most accommodating version. Okay, let's look at this method here. Okay. So now I put a reference type as the return type, okay? Especially this class here is the top of the hierarchy, or it could be anywhere in the inheritance hierarchy. So this is really the main thing I want to trace with you. The student here represents the static type of return value. Of course, the way you can understand it has been is simply return type. I agree. It's definitely the return type. At the same time, since we have inheritance in the context, because student is one of the classes in the inheritance hierarchy, so it's also at the same time the static type for return value. Having that in mind, you will be able to understand a little bit more when you got polymorphic array. Okay? So what we do is, eventually, we want to return something statically that's a students. What about dynamically? Dynamically, the return value could be any of the descendant classes of students. Okay? Let's now write this down. Given that the return value has a static type, students. So that would mean dynamic types of return value can be, let me just write here, can be any descendant class of students. Okay, so looking at the static type of the return value dynamically, it can be any of the descendant classes, but let's see exactly how. So we simply give some integer index. It should be basically should be larger than 0. It should be larger than 0, and it should not be negative, and also should not be too large. It's just about valid index, pretty much like the array index. Okay, for this part here, you can double check with the logic. Okay, so in case the index is not really valid, okay, so this will be the invalid index condition. Okay, if the I is valid, we're going to assign. Okay, let's say we start with some value that we're going to return later. Okay, so we start with students over here. So I deliberately have chosen the student here, matching the return type, just a little bit easier for us to see what's going to be returned. All right. Eventually, we're going to return S right here. Okay. Now the question is, what can be the dynamic type for S? To see that, we got to look at the else part. Okay. You can see the else part right here. Given that the index I is actually valid, we're going to index into this polymorphic array, which we just discussed before the break. Right? It could be I here, could be, for example, I here could be 0 and could be 1. In case I happen to be 0, we will be assigned S to this particular object, in which case it will have the dynamic type resident students. In case I happen to be 1, in that case, we will assign SS1, which will be this object right here, to S. So it has a different dynamic type, right? And then when we return S, the return value may just have different dynamic type accordingly. Okay. So here, let's see this. So 0 means SS0, which we know has the dynamic type resident students. When it is 1, that means we're going to get access to SS1, which will have dynamic type non-resident students, right? Either this or this. Of course, I'm assuming that we kind of construct a similar contents of the array from the previous example. Okay. Any questions so far? Just about the method. All right. Let me recap very quickly. So this method here, the return type over here, at the same time is the static type for the return value. Because the type here is the top of the hierarchy. So that means the return type has dynamically any descendant class of this particular type, which is, can be students, can be resident students, can be non-resident students. And to really trace it, we're going to see this line here. So we might assign different index in the array to the return value right here. In the case where this is 0, we have some dynamic type. In the case where this is 1, we just got another different dynamic type. Okay? But let's see how this can be done. Okay? Let's look at that quickly. Okay? Let's now just assume we already got all the objects constructed, right? So this part here, right? All this part is just about setting up the entire structure right here, right? Again, I would suggest you also try to trace it from scratch and make sure you can do it, because this kind of diagram may not be given to you during the exam. You may want to see how you can trace it yourself, okay? So having this right here. So let's now, we are trying to really call the get students method here one time and then another time. Okay, I'll highlight them. So you can see this will be the first time we're calling it. And this will be the second time we are calling it right here. Okay. So when we are calling that for the first time, we're passing 0. All right. So when we pass 0 here, so that means the I here will be 0, which is a valid index. So we wouldn't go to the if part. So go to the else part. And then that means we're going to go for SS0. Right? So eventually, we're going to assign whatever SS0 is pointing to. So S will be just right here. That's what we are returning, all right, for the first call. And that one there, we know that dynamically it has a resident students objects, right? So after this variable assignments, we know that S over here, after the variable assignments, it will have the dynamic type resident students because it's being assigned index 0 of the array, okay? Of course, you can do the instance of check like what we did earlier. You can do it. Okay, I'll leave exercise for you. We already did it before the break. Just look at this one here. So now when I say s.getTuition, I need to trace to see what's the current dynamic type for s. It is pointing to resident students. So it's going to call the resident student version using premium rates, right? And then we look at a second call to the getTuition, get students. So this one here, we're passing index 1, right? So we're calling the same method here. So now I rather than 0 is going to be 1, okay? And then we are assigning to SS1, which we know is index 1 has this particular dynamic type, okay? So we know that index 1 is going to give us NRS. So S that's going to be returned will be right here instead. Okay. So after this, we know that the S will change its dynamic type from RS to NRS. And then when you say s.getTuition, you're basically calling the version that's in this dynamic type, non-resident students, right, using discount rate. Okay. It's not difficult. I mean, you just have to be very patient to really trace to see which object it is pointing to and figure out the dynamic type to see which version of the method is going to be called. But I think that we are just being too familiar with the student management system example since we've been talking about for 6 lectures already. But I think in the actual exam, I might just give you a different example to try. So you just got to make sure you know how to trace the code and also how to figure out the static type and dynamic type. I think that that's the main thing you want to pick up, right? All right, any questions? We're good? Yeah, go ahead, please.
So we can use instance of the check like the dynamic type of a variable, right?
Of course you can. So for example, right, again, let's just revisit about the meaning for instance of, right? So when I say, let's say here, whenever I got this, I'm basically asking, can the dynamic type for the left-hand side fulfill the expectation of the right-hand side? I'm asking this. At this point, dynamic type is resident students. Can resident student fulfill non-resident students? No, so false. Okay. Yeah. Of course, there's also the compilation issue, right? So in this case, can we cast, let's just go for, okay, CS students. Can we cast as statically as students to non-resident students? We can. It's a downward cast, right? So from students down to non-resident students, it's a downward cast, right? In that case, the instance of will also compile. Yeah. So whenever you talk about typecast, you want to make sure you actually, whenever you talk about typecast and also instance of, always check for compilation and also runtime, right? Okay. Yes, please.
Why is the last line not compiled?
Oh, the last line? Okay, good. Sharp eye. Okay, maybe I missed that line. Let's take a look. Let's look at that. You want to give it a try? It's a good question. I'm glad you actually mentioned that, right? You brought it up.
My guess is because the get student is of static type student. You can set that to non-resident student, right?
Yeah, I think that's pretty much perfect. I would say 98%. Okay, I'll just make it a little bit more complete. Okay, absolutely. So this is a variable assignments. The right-hand side static type must fulfill non-resident students. So now how do we figure out the right-hand side static type? So it's a method call, especially to accessor. So we have to look at the static return type, in which case it is students. Okay, I'll write it down. So this one here, has the static type correspond to the return type, which is students. So now can students fulfill non-resident student? You cannot, so it's not going to compile. Yeah, good, very good.
What if you typecast it to?
Yeah, you may. Yeah, sure. Good question. I like the follow-up. Why don't we try? Let's say hypothetically, we know that statically is going to return a student. So why don't we do a downward cast? I presume you want a downward cast to non-resident students, right? Okay, why don't we do it? Non-resident students. Because it's a downward cast, the cast itself is going to compile. And then the right-hand side right now has the static type NRS, which is going to fulfill here. But now, are we going to get class cast exception? That's the question. You said no? Why not?
Because the dynamic type is non-resident student.
At the moment, it's non-resident student. And non-resident student can fulfill non-resident students.
Yeah,
yes.
we're good.
Very good. Yeah, we're good. Exactly, right? So now you're getting a little bit more independent about what you should really check always. Yeah. Good. Awesome. Okay. All right, so let me do one more. Okay. So now we're basically done with the polymorphic assignment. I want to just say one more example about equals method, just to see which overridden method should be called. This one should be rather straightforward, and also we also kind of mentioned that I think in the earlier stage for the inheritance discussion. Let's take a look. Okay, let's say we got three classes. We got A, we got B, we got C. Okay, the first scenario. Let's say the equals method is not overridden at all in any of the classes. Okay? And then what we have is we actually got some C1 objects, right? C, right? Dynamically it's C. Oh, no. Now with this compile, just variable assignments, we're basically asking, can C fulfill objects? Yes, it can, because C by default is the descendant of objects. We haven't really done this so far, but there's something we kind of implicitly set, right? So we got C1 dot equals C2. So this would mean which version are we going to call? It's going to correspond to the dynamic type for C1. Okay? So here, if you look at C1, we know that the version in the dynamic type, which is C, is call. So that means we go to the class C here. Is there equals method overridden here? No. Go to its parents. Also no. Go to its parents. Also no. That's basically the top of the hierarchy already. In that case, we just go back to the default version. So this will be called. Okay? Okay? That's one extreme case where there's just no ancestor who actually have already has overridden the equals method. Okay. Scenario number 2. We still have the C dynamic type and also C1, right? We're still going to call the C version of the equals. But now in this case, well, this one's simple. Let's say C itself has overridden the equals method. In this case, of course, we're going to call this version. It's right there, right? No choice. Okay, so in this case, we're just going to call this version. Okay, just call this version. So that'll be in C. In the early example, you will call the object version. Okay. Now, how about this one here? So here we got C here and then C1, and then when we get to C here, nothing there. So we go up one level. And then here we see that right away, equals. Do we need to go any further once we have found it? We don't have to. Closest ancestor, that's something you want to remember, all right? So you can think about this is a closest ancestor's overridden version. This is the overridden version of the closest ancestor. Okay, so we're going to call the version from B. Okay. Even if we also have overridden some version in A, doesn't really matter, because as soon as we found the closest one, we can disregard anything that's further. Okay? Excuse me. Okay. All right, one final thing about inheritance. Okay, right here. So this is really at the last slide, I believe, on the inheritance. This one, this table here, kind of summarize about the so-called type checking rules. About if whenever you talk about compilation, what should you satisfy? So over here, if you look at, for example, here, in order for this variable assignment to really compile, you got to make sure y static type must be a descendant of x's static type, right? That's one example. And then exercise to go over all the different scenarios to see under what conditions should they compile. Okay, I'll leave them to you. Sorry, just choking a bit. So over here, so I think that's everything we have been talking about, especially this one here. You may also want to go a little bit beyond, given it compiles. What will be the condition for class cast exception? Right, that's something we did. Actually, it's the first example right today, in the beginning. Okay, so now we are done with the inheritance. Let me just see. So we're done with this, and then, so this is just some reminder about when should you really use a static type and when should you really use a dynamic type, right? That's something we also said earlier in the lecture. So that was just repetition. But you can definitely refer to them, review them also before the exam. And that's a table. And then that's the equals method we just spoke about. And then there's a final one. Some additional exercise you can try. All right? Yeah, now we're done for inheritance. Yeah, question?
Previously, we've been seeing the get class method.
Yes.
Is it useful in the context of inheritance?
Okay, I'm glad you asked. Okay. Yeah, today I wouldn't really cover so much about recursion. I do want to just get some very quick resources pointing, so and then we can be done. Okay, just give me. We can definitely leave a little bit earlier today. Okay, let me just do just answer Daniel's question. That's also something I did yesterday for your Section G fellow students. Let's now compare instance of versus get class. All right. So get class is something we learned back in the object equalities lecture. So let's say this. If I have some variable x, if I say x dot get class equals y, okay, that's one thing. Of course, you got to say y dot get class as well. Okay, if this is true, means x's dynamic type is y, right? Consistent with what we learned earlier, all right? So now we want to compare, what if I set x instance of y? Do you think these two checks are doing the same thing or different? If they're different, what exactly is the difference? We'll give you a bit more possibility, right? Somehow. Yeah. Yeah, go ahead. Yeah. No, actually, so both of the, yeah, you can say that, yes. In order, of course, every reference variable will have the get class defined. So this one here will actually compile no matter what. You don't have any compilation issue over here. But here, yes, you do have the compilation issue here because you must be able to at least cast X to Y. Otherwise, this may not even compile. Yes, that one I agree with you. Okay, what about, let's say, assuming that it compiles? In that case, if this is true, does that kind of guarantee us something a little bit more or equal to what this can guarantee us? I'll try to help you a little bit, okay? This one is a bit tricky, so that's why I want to just give you the answer directly. You can think about it. So let's talk about X. X dynamically is pointing to something. Okay, so this will be X's dynamic type. Okay, just here. We're basically asking, can this dynamic type fulfill Y? Right? It can fulfill Y as long as this is a descendant of Y. Not necessarily a direct child. Well, not necessarily exactly this dynamic type. Right? So let's visualize that a little bit. Okay? Let's say I got this dynamic type is one class in the hierarchy. Maybe Y is not exactly its parents, maybe not exactly its grandparents, maybe it will go up a little bit. And then right here, we actually got Y. All right, let's say that, right? So now, if I know that X is somehow an instance of Y, I will know that at the same time, X can also fulfill everything underneath as well. So that's the thing that can also guarantee me as well. That's not really the get class can tell me. Get class is really comparing is X dynamic type exactly Y, just Y, nothing else. All right. So that's really the difference. Okay. So this part here is something. This is not exactly checked by the get class. Yeah. All right, question about this. It's a comparison, just to see get class and instance of. I would say you don't really use get class that often, except in that standard equality, like a definition, like a phase number 3. But I would say typically, if you just want to see if you can do a typecast, do instance of. That's exactly what you're going to do. It's a safety check. Okay. All right. So now we're good for inheritance. I want to spend just about 5 minutes. Right? I don't think I'm going to talk anything technical about recursion. I want to point to you just about the resources. So as I said, I don't want to dive too much into recursion. It's a very broad topic and very tricky topic as well. So I think for the exam, I will give you the resources just enough so you can definitely master what's needed for the exam. But looking ahead, so after this course, you're gonna get to 2101 data structure course. That one there, you definitely will be required to program much more intensively about recursion. But I think what we're gonna learn this term can definitely help. Okay, I'll show to you about the resources very quickly. Okay, so recursion and the slides, everything is already there. I'll show to you. I would suggest once we start covering about the basic of recursion from Monday, as soon as after Monday's class, or even over the weekend, if you want to already get ahead, with, do a little bit self-study yourself, you can definitely feel free to do it. All the resources are here, okay? So you got the slides over here, recursion, and also this document here summarizes about all the recursion problem that we're gonna go over in the lecture. And the way we kind of solve recursion, we gotta follow certain patterns. And the way we solve them, the pattern will be very similar to conducting mathematical induction, which you learned maybe from your math class before. But if you know, that's okay. I'm going to mention the pattern to you. So you're going to talk about base cases, and also you're going to talk about recursive cases. So all these examples will follow the same pattern. Okay, so I would suggest take this document as well. So review it as soon as we are done with one particular example, just to see how the pattern can be reinforced. Okay. So that's one document there. And then we got lots of exercises for you. So this is one, we don't have any more lab due. We actually got one more, lab number 5. But lab number 5 is not really about recursion. That one is only about inheritance, just one more. So this is a past lab in 2030 about recursion. I think give it a try on that one there. You can definitely practice recursion a lot using that. The recursion problem I gave to you during the exam will be no more difficult than anything here. Okay, so you just got to make sure you master about the pattern. Okay, there's one lab you can try, and also there's a website called Coding Bet. They also got lots of example questions there for recursion. If you go there, I'll show you one example. If you go, especially for recursion 1, they got so many questions here, right? So you can basically go to any one of them, and then they will give you some problem description. They give you some input-output expectation. That's kind of like an interview kind of question you will be given if you ever go to company for interview. They might just give you some informal description, give you some example, and then you got to code it up. Maybe using some IDE or maybe on the board, right? So you can program some solution here and then submit for grading. So they actually have, behind the scene, they have some test cases to run, pretty much like how we did for the programming test. You can definitely try. They got recursion 1, recursion 2. Okay, so these two. And this is like a tracing exercise I'm going to give to you, maybe on Monday, next week. And then all the example that we're going to do, we got all the example code here. And this, sorry, I got to check this link. Okay, I'll double check. Apparently it's not there. Okay, I'll double check. And we got all these coding example, and then there's another tutorial session on extra recursion problem, also around a similar difficulty level. So especially for those of you who will be learning recursion for the first time, you definitely want to dive into these resources as early as you can. You definitely will need recursion for the exam. Okay? All right, any questions? All right, today I don't think I want to cover any recursion thing. I think you can feel free to look at any of the resources. Everything's there. All right? Okay, thank you. I'll see you in the test today.